Yeah, well, thank you for the introduction and also inviting me to talk today in this setting. I'm going to be sharing some of our data and analysis and interesting findings that we're seeing in New Jersey in terms of what we're doing for stream temperature monitoring or how we're doing our stream temperature monitoring and some interesting findings. The talk is entitled Temperature Changes in Brook Trout Streams During Stormwater Events. But at first, I thought it would be interesting to give a little bit of a background on our data collection for stream temperature. And we're doing what I think many states have done and started to plan to continuously monitor stream temperature about 10 or 15 years ago. But in the last 4 or 5 years, we really focused on looking at brook trout habitat and brook trout stream temperatures, where we know we have documented brook trout throughout the state of New Jersey. So we're fortunate in New Jersey to have a pretty good idea of the distribution of brook trout and other wild trout due to historical monitoring that's been pretty heavily done in the northwest section of our state. So we were able to pick monitoring locations primarily where we've documented brook trout, but also where we have other non-native wild reproducing trout species such as brown trout and rainbow trout in New Jersey to look into other reintroduction projects or removal projects. So we looked at 242 locations between 2018 and 2021, and those are the blue dots there on the map to the right. And the objectives of the project, again, were to determine resiliency of cold water habitat, and then also to prioritize protections and projects at those locations, and also identify locations that with some amount of help can potentially be fixed or at least made more resilient to air temperature increases or other impacts that we may be finding. So this is probably a little bit redundant. This was similar to what Jake just spoke on, but we used our air temperature and stream temperature data we collected to create similar projections, and also using similar methodology from Snyder and others, the 2015 paper that incorporated the use of groundwater metric. But the major finding or takeaway was also similar, is that by incorporating direct measures of stream temperature data in our models, our outlook for the future of cold water habitat in New Jersey and brook trout was much more optimistic. And I just pulled out one statistic from our study that our models were able to show that under a warmer scenario of 3 degrees Celsius increase in air temperature, that we'd lose approximately 35% of cold water habitat. And that's looking at a site-by-site basis. So, that isn't good news, but that's just more, as Jake said, it was just more optimistic than previous models that didn't account for fine spatial variation in groundwater influence. But that's a little bit of background on and why we were doing some of our data collection. But, for the real topic of my talk, as we were analyzing stream temperature data, we identified an issue, and this was that many of our wild trout streams were being impacted by stormwater. So between 2018 and 2020, approximately 20% of our sites that either had or have reproducing wild trout documented stormwater impacts. So the heat map on the right there is showing frequency of stormwater events in relation to our stream temperature sites. So we were defining stormwater events as 2 degrees Celsius increases in stream temperature in a 30-minute period during a rainstorm event. So pretty significant. And I'm just going to show what one of these graphs looks like when there is a stormwater event. This is an event that occurred on July 22nd in 2019 and increased the temperature of that stream water 6.5 degrees Celsius. The event itself lasted 16 hours and reached 22.5 degrees Celsius. So pretty extreme increase and spike in temperature there. But just to give you, and this maybe answers somebody's question before of using a thermal infrared camera on your phone. This is an example of that, but looking at stormwater impacts, which it does a pretty good job of at least showing the relative difference in temperature. But this also shows and helps you visualize kind of what's happening during a stormwater event. This is a stream that downstream of this impact used to have brook trout present. But interestingly, above this impact, the brook trout are still there. So you'll probably get an idea or a sense of why they're no longer existing below this impact as you look at the video or a couple of videos that I'm going to show. So this is just to give you a sense. The video splits the image into half thermal infrared on the right side of the screen, and the completed image is on the left side of the screen, just to help orient what you're looking at. So I'm going to pause it right here, or try to pause it right here. So the stormwater drain is at the top of the video. Here I'm going to pan over it. And you can see the thermal infrared image is picking up on that temperature difference. It's saying that there's about a 10 degrees Fahrenheit difference in what the stormwater is dumping into the stream as compared to what the stream temperature is there. And just keep in mind, this isn't just, we're not just talking about stream temperature, even though that's really important. What else is being carried into the stream besides, what pollutants or toxicants are being carried into the stream, causing an impact to the aquatic biota that exists there. So here's just one more. This is another video, and it starts by pointing up what is typically an ephemeral channel. It's actually just acting as a conduit for stormwater from a townhome community, and so again, this is typically an empty channel, and just showing the amount of stormwater that's entering the stream. This is something that our stream temperature loggers picked up on, and I was just lucky enough to be in this area when this rainstorm event happened, and I jumped into the stream, and I'm actually struggling a little bit with my footing. But just to give you a contrast of what the upstream section of this stream usually looks like, it's actually pretty tame, and it's actually upstreams where brook trout are still present in this particular stream. But you kind of, you get the sense of why they no longer exist when you look at the stormwater impacts downstream. For nothing else, I thought the videos were pretty cool. So we looked at stormwater metrics in relation to land use variables to understand their relationship. And the results weren't too surprising here. The frequency of events at each site was significantly and positively correlated to the percent urban land cover. And the metric we used to measure the magnitude of a storm event, which was the temperature at the beginning of the storm and the highest temperature reached during the storm event. And this was significantly and positively correlated to the percent altered land, which we're defining as the sum of urban land cover and agricultural land cover within a catchment. And I think this was significant just because we had a lot of agricultural land in the watersheds that we were looking at that had brook trout and other wild trout species present. But we also looked at stormwater and land use predictors for the absence or presence of wild trout or brook trout in these impacted sites, and found that the best predictor of absence or presence of wild trout was the frequency of stormwater events. You can see with 15 stormwater events, the likelihood of trout being present is only 17.4% likely. And when we think about 15 stormwater events, that's a lot in a summertime period. That's 16% of the summer days. There's a large and sudden spike in temperature and influx of stormwater into these systems. So we had some sites with 9, 10, 13, and 16 events in a summertime period, which is a lot. The other land use predictor that was significant was urban land cover. It's positively at 70% urban land cover, the presence of trout was 9.6% likely. But one interesting thing I wanted to touch on were some of the outliers here, because I thought they were interesting to note. and they also shared a commonality in this data set, that these two sites had impervious cover of 23.5% and 15.1% impervious cover, and that's the highest compared to any other in our data set. And brook trout were actually still present here, and there are some papers out there, I think, noting and documenting when impervious cover is over 4%, it's pretty unlikely that we're going to find brook trout in those catchments. And these are some catchments or streams that were anomalies. And this stream temperature graph to the right shows one of these streams. And you can notice right away the stormwater surge events on this graph. But other than that, stream temperature is relatively cold and not exceeding 16 degrees Celsius throughout the summertime. And again, this is like the commonality, that very cold stream temperature, other than the fact that it's being impacted by stormwater events. And then the other one I wanted to share was this one here, which had a very high amount of altered land. So that's again the urban land and agricultural land combined to be 80% in that particular catchment, and it still has a thriving population of brook trout in that particular stream. But again, as you can see, the stream temperature graph, and if we ignore again the stormwater temperature spikes, the commonality is that the stream temperature was very cold and barely exceeding 14 degrees Celsius, and just kind of making the plug of how important it is to be looking at groundwater and cold temperatures and identifying these locations for brook trout, as even in the face of some extreme conditions, they're holding on in these places that have very strong groundwater influence and cold temperatures. So aside from stormwater stuff, I wanted to share some other things that we've been doing in New Jersey. This is a project that we started this past summer in relation to collecting stream temperature data and identifying cold water refuge. And it's a pilot project to develop methodology to collect data and help identify or quantify cold water refuge within different stream segments on a very fine spatial scale. And I happened to attend a webinar that was being given by NCTC, and it was given by a presenter, Scott Craig, with U.S. Fish and Wildlife Service in Maine. And he was implementing something called the Vaccaro method to do this. So this method, which is described in the paper that I referenced down below there by Vaccaro and Maloy, actually gives you some hard data points. And the thermal resolution is really good, and it's actually quite inexpensive to implement. And that's one thing I loved about this method, was that purchasing wasn't going to be a nightmare, as it usually is. So we used a Solensed barrel logger, which is typically used in groundwater wells. It's very responsive to temperature changes, so it's good for pulling through a stream and identifying changes in temperature. And this thing costs $600. And we paired it with a GPS unit, which we had, but you could get one for around $100, and you're really set to start walking. You just have to find a broomstick in the corner that you can attach the GPS unit to and the logger, and then you're set to go. So you have a really high-tech setup, but you get some really cool data. I think we mapped about 9 miles of stream in 4 days, and got some really neat data. So this is a map showing the actual stream temperature readings that we're taking on a stream called the Upper South Branch of the Raritan River. But another really cool way to look at this is by calculating heating and cooling zones, which I won't get into, but it's relatively simple to do. But this helps highlight areas where we see significant cooling, and you see on the map where those dark blue dots are associated with tributaries. But there's areas where we have significant cooling that may be from groundwater seeps. So this hopefully informs restoration projects or cold water refuge where we can identify things to do in terms of protecting habitat and brook trout. Right. So that's all I got.
Great, thank you, Scott. questions?
Scott, can you put back up the meter, the temperature? Yes, thank you.
Okay, sure.
I don't write that fast. Thank you.
Yeah, absolutely. Yeah, and I think if you're interested, it's probably a better explanation of, I think the webinar is actually still available on NCTC's website. I can, if you're interested, I can send you the link to it, Diane.
That'd be awesome. Thank you.
Sure.
I see a comment from Lee, using the Vaccaro method in Vermont. That's cool.
Yeah, I agree. It's a really powerful tool just to see the longitudinal changes in a river. We've haven't, some of the bigger rivers we've done, obviously with one logger, you don't get complete coverage of the whole river, but you get a more coarse picture of the longitudinal profile as tributaries come in and things mix. So it's I agree, relatively easy to do, low investment of time, spend a few days and you get a pretty comprehensive picture of what your temperature regime looks like.
Right, and you can overlay because this is used in groundwater wells. You can overlay what the depth of the water was and what the temperature was, so you can get to see at what depth, what temperature you're looking at. So if you're going over a deep pool and you want to see temperature there, the level logger is going to identify that you're in a deep pool and then tell you what the temperature profile of that particular pool is in that stream. So it does give some pretty good data and pretty good insight into the stream temperature on a fine spatial scale. So it's neat.
Hey, Scott, it's interesting to note that this is great work, and it's noteworthy that in forested systems, you can see the opposite effect of precip on temperature, right? So there's Eric Merriam's paper with Todd Petty, Brook, Trout, and climate, and the effect of rain, like rain as a thermal refuge. Now, obviously, these are urban systems, but it's interesting. So you included ag in that calculation of disturbance or whatnot. Is it really just an urban signal? Because is that really what's the mechanism here? Because I'm thinking about forested systems where you can see a very different kind of response to precip.
Right. Yeah. So you're saying is it more than just urban that's causing the increase in temperature?
Or maybe just more generally, have the contrast with Eric Merriam's work here. Like, what do you make of that?
Yeah, I mean, to be honest, I don't think I caught that in the beginning, Eric. So I apologize.
No worries. It's just that in forested systems, you can see a cooling effect of precip, in some systems, and so they're attributing this in a climate forecasting realm. Eric's on the line, I don't know, but I think what you're looking at is urbanization, right? So I think it's interesting that the ag component may be part of it. In this region, when we look at ag, we often see colder temperatures because those are fertile limestone valleys. I don't think that's what's going on in Jersey, though. But I think that clicks in pretty good.
Yeah, no, and that's a good point. It was kind of unexpected to see that being connected with warming there as well. But I think I think what kind of maybe confounds it a little bit is that we have, at these places where there's lots of agriculture, we're also seeing a lot of roadway crossings as well, that may be contributing to that warming too, where you see that, just have roadway crossings and then, that rainwater hit that hot pavement and dump into the stream at a lot of those roadway crossings where a lot of those agricultural fields are as well. So it's probably more just a, signal for development in general in New Jersey. Where we do have in the watersheds that we're looking, where we're seeing these stormwater impacts, there's a ton of roads and there's tons of poor stormwater management in regards to that and our kind of our wild trout streams.
Now, we've got a spring-fed system, Edwards Run, we've done brook trout restoration in, and we notice a signal almost like stormwater runoff. It's very cold, spring-fed system, but it's all agriculture upstream of where the main spring comes in. And when we get big summertime rain events coming off that open agricultural lane, it's just sheet runoff. It's not infiltrating into the ground, and it runs down, and it can raise the temperatures in Edwards Run significantly. So it's similar to, it's just an impervious surface runoff.
It's just been solar supercharged without pavement or.
It might fall cold out of the sky, but it runs long enough across a heated soil agricultural landscape that it gets absorbs that heat and carries it into the stream.
Yeah, we've even seen that in the forested system, which Dan, I'm picking up what you're laying down with the temperatures, but if it's completely forested, there's nothing else affecting it. But we've got instances where there's enough of a road network, even in the forested environment, that temperature's being affected by the time it makes the rainfall makes it to the stream.
Yeah, and that's one thing where I believe there's conversation of moving away from using impervious cover as a way of, our classifying waters in New Jersey. It is using that term altered land, which I kind of referenced a couple of times, which is that combination of urban land and altered land, just because it's a better, in some studies, I think they're finding, at least in New Jersey anyway, that there's a better explanation for IBIs and poor scores in IBIs relative to altered land as there is compared to impervious surfaces.
That was a great temperature panel by the group here. Groundwater is all I can think about right now. How important it is. Any other questions for Scott or the other panelists about?
Yeah, Nate, this is Ross. Hey, Scott, good job on the presentation. I did want to also just add something to Scott's presentation, that those two sites that he showed with those huge temperature spikes, I think the one was 6.5 degrees Celsius in a half hour, and the other one that he showed may have been greater than that. We did go out and this past summer to see if we lost any brook trout from both of those sites, and we predicted that we probably did. Not knowing how long these temperature spikes, these storm water events are happening. But believe it or not, they were just spot checks due to the pandemic. We couldn't do our full surveys, but believe it or not, we still did find brook trout at both of those locations. So even with those huge temperature changes in such a short period of time, the brook trout are still somehow finding a way to survive that. Luckily they're very short-lived, those temperature extremes. As I think Scott pointed out, it was 12 or 16-hour events. But even with that, we thought we were going to find a lot of mortality from those stormwater events, but we did not see dead fish. We weren't there immediately after, of course. But surprisingly, we were still finding populations of brook trout surviving downstream of those sites.
Wow. I think there's a chance they know and they migrate and go back.
I think it would. They're just so quick. That's an afternoon thunderstorm where it just dumps a half inch to 3/4 of an inch of rain on that into the system, and at least both locations are there's a pond involved, and that extreme heat, we believe, is that pond then tops, and that surface water just dumps directly into the stream, or it's a like a water, what do you call it, sorry, I'm blanking on the term, but like a catch basin that's doing the same thing. They're just either not designed well enough, or over time, like in the one case, it's a pond that there's a lot of new impervious surfaces that are just being piped into that pond and on these flows. So I really don't think it's migration. just because it's so fast. I mean, they'd have to see the storm clouds coming and then make a run for it type of thing. We're just assuming it's just the fact that it's short lived. But I know a lot of research papers out there say if you have that kind of extreme temperature change, that's lethal. But possibly we have a population that's evolved to deal with that maybe a little bit better than the current literature states.